I want to continue the introduction to geography in general by talking about physical geography. So our chapter 1, some of this may be vary or maybe go into different level of detail than our chapter 1 in the book, but I do want to kind of pull some very essential information from some of the other classes I teach to introduce you to the physical environment of the Earth. All right, so landscapes. What are landscapes? These are collections of things like mountains and valleys. And so let's first talk about the physical environment of the Earth, the actual rock layer. And maybe one of the simplest ways of thinking about how you get the landscapes you do, like for, say, Yosemite Valley, is that these are what we call processes, things that either are building up mountains and other kinds of features on the Earth. And at the same time, you have processes that wear things down. We call that denudation, or wearing things down. And so when we look at if places are flat or if they're mountainous, it's really the interactions of these processes that give you these different types of environments. And one of the main processes on a global scale worldwide is a concept known as plate tectonics. And plate tectonics is the way it works is the Earth is kind of broken up into, without going into a heavy level of detail, the Earth is broken up into a number of different kinds of what we call tectonic plates. So the outer layer of the Earth is on these plates, and these plates move around. If you look at the arrows, here the North American plate is moving that way, and the Pacific plate is moving up this way. And California here, it's hard to see, sits on both the Pacific plate and the North America plate. And the Pacific plate is moving up quite rapidly to the north. And the boundary between those, that's San Andreas Fault. That's where we have earthquakes in California. And we have those because of that boundary between these tectonic plates. Other places like we're going to look at the Himalayas in India. These are created because there is one part of the Earth that is India is being crushed against another part of the Earth that is in Asia. And we'll look at other phenomena throughout the course of examples of how these tectonic plates shape some of the physical landscapes. So just some background that, the idea of plate tectonics is actually a relatively new concept. It starts with what's called the Continental drift theory. A scientist named Wegener theorized that the continents at one time were together in one supercontinent called Pangaea, and like hundreds of millions of years ago. And he went out and collected evidence, and it was, there's a lot of strong evidence that the continents that we see today as separate were at one time put together as one big continent. So that's a concept called Pangaea, and the idea is that these had drifted apart at some point over time, and it wasn't accepted right away. And actually, until people really learned about tectonic plates, it was hard for people to imagine how they could move. And it turns out the way that the continents drift is because it's not just the continents, but it's these plates themselves that the continents are sitting on that are in movement. And it really wasn't until we could see the landscape underneath the ocean that we could make sense of it all. So during the Cold War era, after like in the 1950s, when we had submarines mapping the ocean floor, we began to find evidence of where the boundaries of these tectonic plates were. And then over time, we've been able to develop theories about how these continents are able to move around. And the idea is that where you have continents that are being broken apart from each other, you have, they're spreading apart. And this is happening in many of our oceans, like the Atlantic Ocean. And then likewise, we have places where where the crust of the Earth is being pushed together. So here, part of the ocean floor is subducting or being compressed against the continent. And as it does that, the subduction actually pushes it down deep within the Earth. As that happens, the rock melts, and it actually drags water along with it, and the melting and the water combine to do things like create volcanoes, for example. So volcanoes, earthquakes, a lot of these are tied along with these processes. Actually, the volcanoes, the earthquakes usually happen because of movement of these plates, that where they come together, being pushed together or sliding past each other, that breaks rocks and causes a release of energy we know as an earthquake, like along the San Andreas Fault. One of the most active parts of the Earth with earthquakes and volcanoes is around the Pacific Ocean, and this is known as the Pacific Ring of Fire, because there are a number of active plates all around the Pacific Ocean and a whole lot of volcanoes, earthquakes, and so on. And plate tectonics and things like volcanoes and earthquakes are largely responsible for building up the environment, for creating mountains, for creating islands, things of that nature. But I'm just going to show you this graphic. Then what happens over time is through processes like weathering. So rain and air will weaken rock. And as rocks become weakened, gravity can roll them downhill. We call that mass wasting, just the movement of material by gravity. And lastly, things get washed away by rivers and wind and by ice, and that's called erosion. And so the combination of plate tectonics and these sort of wearing down processes is what gives us our physical environment that we have today.